everyone for coming today. I'm Jen, and our team today is going to talk to you a little bit about our work in navigating color vision deficiency in the first year chemistry lab. But to begin, we want to first acknowledge our funding sources that made this project possible. So first up, Learn Sci and CLEAR for bringing us here today and supporting us along the way. Of course, Dalhousie University, our Department of Chemistry, Center for Learning and Teaching, and the Office of Accessibility and Accommodation that supported this work throughout the past couple of years as well. We are a four-person team, so Nick, Rory, and I will be talking today, and Mark will be present in the chat, which I know has been very active today and has been for all of the CLEAR conferences that I've attended so far. So just a little insight to color vision deficiency. Color vision deficiency, or CVD, affects approximately 8% of males and 0.1% of females worldwide. This is characterized by a difficulty or inability to distinguish certain colors. There are three general types of CVD, and they all stem back to how the cones react and interpret light. So there are three types, as I said, but we're going to focus today on one of the most common ones. The one that we see most often in our lab is Deuteranopia, where the green cones are minimal or almost completely absent in some cases. Folks with Deuteranopia tend to confuse colors of red, green, blue, or purple. And this is of particular interest to us because we've estimated that approximately 105 students in our course and about 3 of our teaching staff at any given time per term are experiencing the lab with a different view of color than the majority. We've also noted that there's 10 out of 16 of our first year chemistry experiments that do have some aspect of color related data interpretations associated with them. And if you happen to see a full spectrum of color in the images that you see here, we've added the spectrum of what folks might see if they have Deuteranopia. And you can see very quickly in that case how these experiments, even though team-based in this particular instance with the universal indicators and column chromatography, that could get really challenging really fast. Of course, because they're team-based, teammates will generally help each other to distinguish colors if this is a challenge for one teammate. However, this can be very difficult if it is an individual experiment, and some of those colors tend to disappear for an individual. So I'm going to turn things over to Nick, who can tell us a little more about that.
Okay, so do I have access?
I think you should, yes.
Is it out of screen for anyone else? Is that just me?
I think it popped out for you, yeah. There, you back in?
Okay, there we go. Yes, sorry, that's really weird. Okay, so in keeping with the theme of CVD in the first year chemistry laboratory, on the left here, we actually have 2 different sets, or I guess the same set of titrations, but one is with your full spectrum of color, and the other is if you have Deuteranopia or if you are red-green colorblind. And the largest and starkest difference between these two is actually between the endpoint with 3 drops. So if you notice on the top, you might be able to see that there is a light pink that we observe at the endpoint from the indicator that we use, whereas at the bottom, there's very little, if any, difference at all. And while we can fix this with upping the contrast or even using more drops of indicator, this doesn't fix the main issue of that, and these are undesirable in terms of we want all students to be able to complete the lab in the exact same way fairly. It doesn't also help that many instances, students often don't feel comfortable disclosing their issues with disclosing that they have difficulty seeing color. So we received an anonymous comment from a student at one point saying, "I feel like I am cheating if I ask you to confirm that I have assigned my colors correctly," which is not something we want to instill. We want them to make sure that they feel comfortable making their own conclusions or drawing their own conclusions and making their own observations throughout the lab. So this presents the very interesting problem in how do we actually tackle this issue of color deficiency without completely overhauling the lab and just starting with something different. And so one way we might be able to do this is by using color filters. So as we mentioned before, Deuteranopia, you're typically missing your green cones. So shown here are the 3 absorbance wavelengths of your actual cones in your eyes. So you have your short or blue cones, medium or green cones, and then long or red cones. And people with Deuteranopia typically are missing these, and then the rest of your eye kind of compensates for that. What Enchroma, which is a type of colorblind filter glasses, does is it absorbs, or it has a maximum absorbance in this wavelength here. And what that actually does is it affects the light coming into your eye in such a way that blocks out all of the blocks out certain wavelengths, which should in theory up the contrast of what you're seeing and return a normal color vision. So we wanted to test the efficiency of this, as well as something we'll talk about a little later, which is our color filters. And to do this, we titrated. So we titrated KHP against sodium hydroxide with the phenolphthalein indicator as normally done, with 2 individuals of CVD and a control of 2 other individuals. And we wanted to see with either out in the aid and chroma glasses or with the custom filters that we're going to talk about in a second, how the actual percent variance in error differ between the two. And to talk about that more, I'm going to pass it over to Rory.
Great, thanks, Nick. I think I requested slide control here. Here, I'll share my screen.
Oh, you're good, Rory.
You're good?
Mm-hmm.
Oh, perfect. Great. So as Nick mentioned, we wanted to quantitate this experience in titrating in actual, in a situation where it's truly quantitative, where color's very qualitative personal experience, okay? So what we did is we wanted to compare the Enchroma glasses in determining the endpoint as versus comparing with a no visual aid itself. And so what we did to quantitate this was determining the number of moles experimentally of our monoprotic acid, or KHP. And then we found the variance with respect to the moles that we actually weighed out of our KHP. So presented on our right here are the percent variance between the two. So in the upper right, we have our CVD individual group. And what you can see is with a variance that's closer to 0, this would indicate that you're actually getting closer to the theoretical amount of KHP. And so you're actually getting a more accurate result. And so what we can see with these CVD individuals is that the Enchroma glasses, we actually were achieving a variance closer to 0, so more accurate results as compared to the no visual aid controls. And then we actually had a control group of 2 individuals without CVD. And what we found is that the variance between our Enchroma glasses titrations versus our no Enchroma glasses were very comparable to each other. So there wasn't really any differences. And we were kind of surprised by this. We didn't expect this because we thought the visual aid of color enhancement would actually be experienced by all individuals. And so I'm going to talk a little bit about this in a later slide too as well. So this was very optimistic. We were pleased that we were seeing an improved color perception with CVD individuals using the Enchroma glasses. But I want to point out there are some drawbacks to these glasses. So these are not lab safety glasses. So implementing these in the university just wouldn't be safe. And it could be cumbersome going over top of our present lab glasses. Also, these could be cost prohibitive too as well. So these glasses, each set costs just under $400 Canadian per pair. And so implementing this throughout our large classes, our large laboratories, could be cost prohibitive. So what we proposed was to be able to design our own notch filters that achieve similar spectral notching as the Enchroma glasses. So presented on the right here is Enchroma absorption spectra profile. So what we actually did was we took the Enchroma glasses and we put it right into a UV vis, and we wanted to see how they actually absorbed or what lights were being, what wavelengths were being allowed to be viewed. And we found a wavelength of just under 600 nanometers as where the notching capabilities occurred. And also this notch had a peak width at half max around 35 nanometers. So what we proposed was to design our filters, our optical filters, having similar spectral properties as these Enchroma glasses. And so we had a few different iterations, let me be honest about that, of making these filters. So we tried using different sol gel chemistry. We also used polyacrylamide gels and films, but it ended up coming down to the best method to be able to make these is using a polyurethane film actually purchased from our local hardware store. The reason why is these films actually cast better, and they were actually more transparent than our chemistry-based films that we were pursuing. So the way to make these films using the polyurethane was we selected a dye having a similar absorption spectral profile as the Enchroma glasses. So in this case, it was an ABS 594 dye from Luxottica. And we doped in a small amount of that into our polyurethane, about 4 mils of polyurethane. This is a solvent-based polyurethane, but you can also purchase water-based polyurethanes too as well. So if you have issues with solubility of the dyes, having this type of system actually makes it more flexible. So doping our small amount of dye into our polyurethane and just drop coating it onto a clean glass lens itself. And then we let it cure for 24 hours to remove the solvent. And on our lower left here, this is actually one of our films onto one of our glass lenses. And so you can see that it's very transparent, and we have it's also colored too as well for our notching capabilities. And so presented on our right, we have our Enchroma glasses absorption profile that we presented earlier. But then we also have our filter that we actually measured. And you can see it has very similar spectral properties as according to the dye that we doped into this. And also we actually have a tighter notch itself. So our peak width at half max is about 30 nanometers. So we made the film and the filter, but we wanted to put it to test. So again, we performed the titrations using phenolphthalein and acid-base chemistry. Looking at the results on the right, you can see that they perform very similarly as the Enchroma glasses. So there are CVD individuals, they actually had a variance closer to 0. So again, achieving more accurate results using the filter itself. And again, surprisingly, our control groups, we didn't really see any changes between using the filter or versus not using no color aid itself. So putting this all together, we were quite optimistic and happy with our CVD individuals in our groups that we were having a higher accuracy, and we were seeing a benefit results of using these types of notch filtering capabilities, both with Enchroma as well as our in-house prepared filters, as compared to not using any filters at all. And so what we are proposing, we think the reason why we're actually seeing this enhancement of color differentiation is when the CVD individuals were doing their titrations, they could actually see the light indicator changes occurring in their solutions before the actual endpoint is reached. So those light, small hue changes when using the notch filters, you could actually slow down your titration and you actually get a more accurate result. Now, contrasting this, we don't know 100% why our control group or non-CVD individuals weren't really seeing any enhancement, but possibly this could be due to these individuals can actually see those faint hues already, and so they weren't getting this enhancement. But more needs to be done pursuing that to as well to fully understand it. So I'll pass the presentation back to Jen.
All right. So just a quick note about the broader impacts of this project, because we've presented a really narrow view of what's been going on. More broadly, this project has impacted online and blended learning color vision deficiency supports as well. What we've noticed globally is increase in awareness, accessibility, inclusion, and belonging in our laboratory because of the visibility of this project. We've seen changes in language of CVD students and how they approach us about it, from exclusionary to things like Nick mentioned earlier, I feel like I'm cheating, to, our team would like to opt for the colorblind friendly unknown, or I felt in control of my learning in my experiments. And something else that's really important to students that kind of came out of all of this was that they really appreciated having the CVD supports embedded into pre-lab talks, into the lab manuals, into everything else, essentially, so they knew about it beforehand and they didn't have to ask, it kind of just existed. And particularly so they appreciated it when this came from an individual on our teaching team that actually has CVD. So they found a connection there. And the most to our delight, I suppose, is, you know, the students that came forward, aspiring chemists and engineers with CVD who have asked, how can they help? How can they get involved? And they've just offered so much insight and wisdom and experience to kind of enrich the work that we're doing. And we hope to bring those folks on board as well. So, I mean, as an outcome, I don't think we could have asked for anything better than what we see here on this slide in particular. So just to end, if you are interested in resources or a full list of references, you can access it at the link provided there on the slide, and that will be accessible until May 20th, 2022. Many thanks to you all for your wow. Jen, words. Many thanks for your attention. And if you've got questions, we'd be happy to answer them and participate in the chat.